today I would like to share about the statistics software. As part as my knowledge, I will share about the statistics software. So today my presentation title is Empowering Data Analysis and Visualization with App Software. This is my presentation overview. Firstly, I will introduce about the art, and then I will show how to build at the data, and then how to import the data to app software, and then I will share about the packaging and library of the app software, and then I will compare the data visualization between app software and other statistics software, and then I will show how to work with the big data, and then I will show live demonstration for using app software, and then finally I will make the conclusion. So firstly, I want to say why we use the app software, because app software is free installation software. That means that you don't need to worry about the licensing or packaging or payment, because you can use it freely. And then nowadays, app software is hotter trend because of their capability. And then this is the independent platform. You can use any operating system, Windows or MacBook or anywhere you can use. And then app software support for different file format. That means that in app software you can use any data format, CSV file or HTML file or any format you can use in app software. And then app software support the thousand of packaging. That means that if we want to create some plot or data visualization, we have to download some packaging for creating the some plot or data visualization. And then now a lot community or user are using that software, as I mentioned, because of their capability. So firstly, I want to introduce about R. R is a high-level language that allows user to write a script for automatic statistical analysis and data manipulation. That means that if we want to analyze the statistic, or if we want to create a plot, you have to write a script that's called function. So for example, we have the data table that is the collecting data for treatment and control, dia A, dia B, and dia C, and then the len is the data for this treatment with full replication. For example, we want to calculate the ANOVA for this data. We need to write only the one sentence AOV len treatment data equal table. So if we write this language, this function in app software, this app software will give out the answering of for ANOVA, for example ANOVA value, and then how much significant different, and then what is the confidence level, like that. So R is the language system using software. If you want something, you have to write the script based on function. So another one is data building. Data building means that in our software we can build at the data table by using the basis function such as vector, matrix, or data frame. For example, we want to write the numeric data 1, 2, 3, 4, 5. Otherwise, any data or any character, you have to write the beta. The beta symbol is C. If you use the beta symbol, you can write the numeric beta or character beta. You can create in app software. Another one, you can create the metric data frame. For example, we want to create the metric data, data 1 to 6, and then row is how much, column is how much, like that. And then we write the function metric 1:6. And row means that how many row, and then and column means that how many column, and like that. If we write the function, and the app software will create the metric data. This is especially in our area, in our research area, we have some data. We need to data table. Normally we create the data table in our software, like writing name is school, or for example Jane Paul, and then age is 25 30 22. Like that we create the data table in our software. So like that in our software also we can create the data table by using the function data frame. So that's mean that according to this slide, in our software also we can build at the data table easily. So another one is data import. So for example, we have big data, thousand or data, otherwise 100,000 or data like that. If we have big data frame, firstly we will create in Excel normally, and then we will import to our software. So that means that we can handle big data or small data by using the our software. If you want to create it in our software, you can create by using the method or method or data frame, as I mentioned the previous slide. Otherwise, if you had the big data, you can create in Excel the data table, and then you can import to our software. And then I want to share about the package and library. Normally, only if we want to calculate the same statistics, or otherwise if we want to bar graph or pie chart or line graph in Excel, we had to click something. For example, we had to go to inserts, and then we had to go there, same graph, and then bar graph or pie chart or line graph. Like that, we had to click, because in Excel they create the function in there. So like that in our software also, if we want to create something, we had to download the package to your computer. That means that our software already create the function in packaging. If you want to create something, we will mention this packaging, and then that this time the app software automatically create what we want. For example, here I show the real line plot. So if this real line plot, we want to create this real line plot, so we had to download some packaging to our computer. So we will command, we want to create real line plot, so the app software will create the real line plot automatically. So that means that if we want to create something, we had to install the packaging to our computer. But we don't need to worry about the packaging. This is free. We can download it freely. So another one is data visualization. I want to compare the data visualization between our software and Excel. For example, we have data. For example, this is the comparisons of scattered hormone between the non-castration, castration, and female animal. So I have this data. By using the Excel, we can create a bar graph. In this figure, we can see which one is the highest one, which one is the lowest one, which one is the significantly higher, like that. And then we can see the every value from this data. That is all in Excel. So by using the our software, we will create other plot. For example, bar line plot, box plot, and real line plot. So according this picture, all is same. That data visualization is different, data explanation is different. That means that I use the same data, but software is different. That's why data visualization and data explanation also different. So as I mentioned, in bar graph we can see which one is the highest, which one is the lowest, and how much the every value. That is all. But the bar line plot, box plot, and real line plot that created by our software, we can see the data variation, data frequency, and then how much the mean value, which one is the higher one, which one is the lowest one, within data also, which how much is the lowest, how much is the highest, how much is the mean value, and then we can create a significant value. So by using that our software, we can create a better data visualization than other software. And then by using the R software, we can calculate many statistical analysis. For example, described it as statistic. Described statistic mean that mean, median, or and standard deviation. So that means that we can calculate the mean, median, and standard deviation. For example, we have this kind of big data. In here, I cross the same part of the data because this data table is so big. So I cut out the same part of the data. So I show the head of the sys row and tail of the sys row. So for example, this data is row is 1 to 725 row. That means that this data is so big. And then colon is cis colon, language, age, height, small, gender, and caesarian. So from this data, I want to calculate mean, median, and standard deviation. Normally in AZ, we will calculate mean, median, and standard deviation by using the sum function. We will calculate separately. In R, we can calculate mean, median, standard deviation, maximum value, minimum value by using only one function. This function is summary data. So if we use this function in our software, that our software will give the all described statistics, mean, median, minimum, first quartile, third quartile, maximum value, like that easily. So that means that by using our software, we can calculate the statistic also than other software. And then other thing, we can calculate the hypothesis testing. That means the t-test, chi-square, or ANOVA. That also we can calculate easily by using the app software by writing the simply one function. It will be len treatment data liquid table like that. So if we write this function, the app software will give out the results of the ANOVA. So how much the ANOVA results and how much significant difference and how much the complete level. And then if we want to calculate the within treatment, that means that how much significant difference between diet A and control, how much significant diet B and control. Like also we can calculate simply by using that app software by writing the one simply function taki ast like that. So we can calculate anything easily by using the app software. So other thing in our software, we can working with big data. So this is the big data I have. This big data is from row 1 to 725 data. So this data is lung capacity or the gender, female and male. This guy is smoking or non-smoking, and then age is how much like that. The collected data. So that means that this is the lung capacity or the gender data. So from this data, I want to calculate lung capacity data of female. So I want female lung capacity data. This female should be older than 15. So in this data, age is there. Each data is very complex because of 6 year old, 18, 16, 14, 5, 11, 9, 18. So I want this female is older than 15 years old. And then this female should be smoking female. So I want lung capacity data of female who are older than 15 and smoking. Normally in AZ, we cannot do this kind of separating from this data. Very difficult. But in R, you can separate by easily by writing the one function. That means that what we want, and then we write the function only one sentence. So our software will create this data. This is the female lung capacity data who are older than 15 years old and smoking female data. So in Excel, we cannot create easily, but in our software, we can create easily by using the simply data. So that's why by using the app software, we can work with big data easily. So now I will show the live demonstration by using the app software. So in here, I have data, comparison data, SCA2 and Indo comparison data between non-castration, castration, and female. From there, I want to calculate the ANOVA for SCA2 hormone between non-castration, castration, and female. And then I want to know how much significant difference between non-castration and castration, non-castration and female, castration and female. So by using the app software, we can calculate easily. So we will write result, and then we will write AOV, and then we want to know the SCA2 calculation. That's why we can write only this SCA2, and then our data is says, data is data, and then we want to know the result. So that's why summary result. So the R is easily give out the data, the answer for the ANOVA. So F value is 2.804. So P value is 0.113. That means that they are not significant different because the P value is higher than 0.05. So that means that our software can create the ANOVA results easily by writing the two sentence. So we want to know the significant difference between each treatment. So we will write a Turkey ASD, and then we want to know this result. So this data is the significant different or not significant different data between each treatment. In here we can see there's no significant or significant difference between female and castration, non-castration and castration, non-castration and female. So that means that by using that app software, we can calculate ANOVA or t-test or chi-square test by writing the simply function. So finally, I want to conclude about the app software. So app software is free installation software. We can calculate any statistical analysis by simply and easily, and then we can get the good data visualization by using the app software. And then now the many user is using app software. So if we don't know something, we can find a solution in Google or YouTube or somewhere. So that's why app software is hotter trend in this day. If you want to study deeply, you can study in my YouTube channel. I post about the app software from part 1 to part 23. That means the basis to advanced level. And so if you want to study deeply, you can study in my YouTube channel. So finally, thank you all. So happy nice day.